Okay, so this will be the last section for chapter 5, that is 5.4. So now we are at the area or areas of tail or tails of what distribution. Okay, so just as we did early on, normally we are given a value that the probability of A is greater than some value. We want to find the probability, but now we are given such a probability and we want to find a value that actually give us what? That kind of probability. So at the end of 5.3, I demonstrate some kind of what? An example. So we have some definition when you talk about left tail, right tail. So the left tail is that the value that's cut off what? The left area of what? Of our density function. And the right tail is the value that cut off what? The right tail of what? Of our density function. So as you can see in the diagram, we have it demonstrated. Okay. So here we are going to the left tail, okay, and this is the right tail. So this is the value of our S random variable that cuts off what? The portion of our density function f of s, and this is the left tail, okay, the value that cuts off the portion of our density function. Okay, so that is the idea of left tail and what's right tail. Okay, so now what you want to do is that sometimes you want to find our S back. Okay, so how do you find our data back when you are given such a probability? Okay, so suppose S is normally distributed, then it has the mean of mu and the standard deviation sigma. So for us to get our data value S back of X, that's the random variable, that's cut off a left or right tail of the area C in the distribution of S. Then what you do is that you first find our Z, and when you get your Z, you can get your S back. The reason being that the formula for Z, as we know, so we have the Z to be equal to our S minus mu all over sigma. So in case you want to get this back, then you do something we call the change of subject. So you multiply here by sigma and here too by sigma. Okay, so you are left with sigma Z is equal to S minus mu. So what we do next is that we add mu to this and we add mu to that. Okay, so this will cancel off. Then our S now is mu plus Z what? Sigma. Okay, so what we don't know is this, because this should be given, this will be given. What we are left to find is what is this. Okay, so that is the whole concept. But with the use of our calculator, the calculator will give everything that we want without going through to find what of our Z. But so we want to actually get to it and get to know how to find our value S back. Okay, so but find the S value back. These are the values we need to get the S back. Okay. All right, so let's get to solve some example. Okay, so we want to find our S star such that the probability of S is less or equal to the S star, and the probability is 0.9332, where S is a normal random variable with mean. So we are giving the mean of the normal random variable to be 10, and standard deviation is what? 2.5. Okay, so how do we get our S back? With the given what? Probability. So note that this probability is given to the left of it. That's the area to the left of our density what function. So the calculator works by giving areas. We have a formula, we have a tool that can help us get this S back. But what is that it only take the areas to the left. So we only need, we have to take areas to the left. So if your area is to the left, you are good to go to input the area there. But if your area is not to the left, then you have to subtract the probability given from 1 to get to your area to the left. Okay, so since here this sign tells us where our area is, so the less than means that our area is what is located at the left, and greater than would mean that our area is to what is to the right. Okay, so let's get to how to find this number. So we use the inverse. So you go to your calculator. And you hit the second and you click on the verse. So you're going to see the inverse as 3. So you click on the inverse, it will ask you the area. Know that this area is given to the left only. So since we have this area to the left, then you point it to go at point what? 0.9332. Okay. And now note that S has a mean different from 0. So our mean is what? 10. And our standard deviation is 2.5. So my standard deviation is 2.5. Okay, so we paste it. Then that will give us the S value that actually generated, that gave us this area. Okay, that's it. But note, before you can use the inverse, make sure your area is to the left. It's to the left. So if for you to know that it's to the left, you realize that you are using the less than to show that you are going to the left, and the greater than means that you are going to the right. Okay, so we have another example here. Okay, so we apply the same principle. We apply the same principle to get our S back. Okay, so we hit the second and we hit the verse, and we're going to go to the normal CDF. Then what is the the inverse norm. So notice inverse norm. So let's press. So reverse, then you go to the inverse norm. Okay, so it tells us the area. So the area given is point what? 0, 427. Then the mean of the random variable is what? So you have the mean to be, so the mean is 12, and you have the standard deviation to be 5. So we do same. So you have the mean to be 12 and the standard deviation is 5. Okay, so we paste it. Then we calculate our inverse. So the answer is 3. So S value is what? So where is the S value that actually generated this area? So we have it to be, okay, that is it. Okay, 3.9. All right, so that is it. That's how we can get our S value back. But the idea behind is what I proved early on. So there's the idea behind for us to get it back. Okay. So now, here we are giving the area to the right. So what we need to do is to convert this to area to the left. How do we do that? This is same as writing, that's the probability. If you recall, you can complement it. So this is the same as writing, this is what I'm solving. So this is the same as writing probability of S less or equal to S. This is equal to 1 minus probability of what? S greater than what? S. Okay, so we know this probability. So it's the same as what? 1 minus. So this is given in the question to be this. So 1 minus point what? 1, 2, 3. Okay, so subtract this, you get this. So now you have the area to the right. Then you can find your S back. It's the same as the S there, will be the same as the S there. Okay, so that's the idea behind. So always when you're giving to the right, make sure you take it to the left. So this is how it's been done, and you use your calculator to find it. And the calculator, so the area to the left, and this will give you this answer. So this should be our S, that is 12. Okay, we do the same for the next. So this also the same approach. Then we get our value S here. Okay. Okay, so let's check this. So we have height of women are normally distributed. We have the mean is 63 inches and standard deviation is this. We want to find the height. So this is the value we are finding, not the probability. So we want to find the height, that is the 10th percentile. Note that you might have some lot of values and you know how to calculate what percentiles. Okay, so we have a lot of values. And let's say these are the heights and for each year. So this is the height I'm interested in. And I realize that this height value is the 10th percentile. This implies that 10% of my data is at or below at this value. Okay, so this is the proportion. So it implies that the probability that S is less or equal to S is what equal to 0.10. That's the same idea. Okay, if S is normally distributed, so all values less than what? S. Okay, so it's the same as writing it. So now we know our area. Then we want to find this S. This is to the left already, so we are good to go. So that was the idea implemented here. So that's the idea we have here. Okay, so we have the area to the left, that is 0.10, and we have the mean, we have the standard deviation, and we are good to go. We do the same, the height, that is, so we want to find another value, maybe it may be here, so the probability that S is less or equal to S, which gives us 0.8. Okay, so you punch in 0.8 there, and you fill in the mean and the standard deviation, and that will give you our S. So this is our S, and you are good to go. Okay, I hope it's more understandable. In case you have question, please do or to reach out to me. So let me check the actual question here, then we come back to this to discuss further. Okay, so now here I want to, so these are test of a new light led to an estimated mean light. So you have the mean to be this, okay, and the standard deviation is given. The manufacturer will advertise the lifetime of the bulb using the largest value for which it is expected that 90% of the bulbs will last at least that long. So 90% implies that we've given but some kind of probability. Assuming bulb life is normally distributed, find that advertised value. Okay, so now we want to find the probability. Okay, let's go back to the question. So let's go back to the question. So now we have been given probability. So we are saying that probability of S greater or equal to S is equal to 0.9. That is what we are given. We want to find this value. That is all. Okay. So since this area is to the right, we want to convert it back to the left. So subtract this from 1. So it's 1 minus 0.9. Use this area and use it in the calculator. Okay. Then you use the mean of it. You are going to get back your S. You're going to get back your S. So that is what we did. Okay. So that is what we did, and we had our answer, right? Okay. So we had to solve some past common final questions, and this needs some kind of an in-depth idea of what we've learned so far. So we have letter grades will be assigned in a multi-section. So multi-section, okay, course according to the principle that the top and bottom 5% of final grades should be awarded what? A's and what? F's. So we have A's and F's. I don't know where my pen is now. Okay, it's not working. Okay, so we have A here. Oh, okay, so you have A and F there. Okay, what is this? I think my parents not showing a sign. That is working. Okay, all right, so it's fine now. Okay, so we are A and F here, so these are 5%, okay, and or the finals, okay, respectively, and the next 10% will be awarded B's and D's. So we have B's and D's, and we have 10% here, okay, right. And the remaining middle, that's 70%. So middle 70% will get it, will be awarded C. A final scores this semester are normally distributed. So we have with mean, so we have the mean to be what 68 and the standard deviation of what 9.9. Then the range of scores that will be awarded C's. So we are going to find this range. That is what we're interested. So we're going to find from this to this point. So this should be our S1 and this should be our S2. This is the middle part we're going to find. So we're going to find the probability that our S1 is less than some S, less than some what? S2 gives us 0.7, gives us 0.7. That's a 70%. So these are the values you want to find. Then it will be good to go. Okay, so how do we do that? So what we do is that we will consider since the calculator gives us left areas, this implies that if you're at S2, so S2 will be the upper bound. Then if you're at S2, if you are here, then you consider the area to this point. So you have 70 plus 10 plus 5, which is as what? 85. So probability that our S is less than S2 is what? 0.85. So we find this. Then we also find our S1, that is the probability. We have 10 and 15. So we have to find probability that our S is also less than S1. Is what? 0.15. Okay, so we find these, and all these areas are to the left. Okay, either with less or equal to or less than, give the same answer. So you can use our inverse formula to get this and get that. So that's what we're going to do. Okay, so with the mean, so the S2 is equal to this. We have the left area to that. So we have the mean fill out. We do the same for the S1. So this should be our S1. And realize that this will give us the values that we need. And what are the values? Okay, so this is 78. All right. So this gives us the value that we want. I believe you understand how we were able to find it. Okay. Now let's check the last question too. In case you don't understand anything, please just let me know. And we have the yield of wheat on unirrigated land owned by a commercial grower is normally distributed with mean of 42.3 bushels and standard deviation of 2.4 bushels per acre. The probability that a randomly selected tract of unirrigated land will produce at least 40.5 bushels per acre is about. So here you won't find the probability. And how do you represent this in terms of in mathematical notation? So our aim is to find the probability that S is greater or equal to 40.55. Okay, that's the whole concept. So now we are not finding an S. The S has been given already. I won't find the probability. Okay, what probability gives us this S? Are you okay? That's the concept. So here you have to know how to differentiate between them. So this we use our normal distribution, the calculator approach. So this will be we pick from here to infinity. So this will be a lower bound and this will be an upper bound, a high value, because it has no limit. It can go like 10,000. But we maintain the mean and the standard deviation here, and this gives us the probability. So this will be our answer. So that is how we're able to find it. Okay, so that is all. I think that's all for chapter 5. Thank you all for if you are watching this and you have any question, and in case you want to also get these videos whenever I post it, you can just follow the link when I post it on Canvas, and you can always get a hint that I've actually uploaded something on my YouTube channel. You can subscribe to that. Okay. All right. Thank you all. Bye.